back in July we looked at the Mango Pi MQ Pro, a new RISC-V or RISC-V based system on a chip dev board in the Raspberry Pi Zero form factor. The new hardware used the Allwinner D1 64-bit CPU, one of the first full system RISC-V architecture chips that was capable of running a full system and not just a microcontroller. Well, many of you have since asked about running RISC OS on such devices, and I do have to admit, RISC OS on RISC-V does sound quite cool, but is it possible? Wi-Fi Sheep would like to say a huge thank you to all of you that kindly support us. Help us continue to bring new videos like this. Join patreon.com/Wi-Fi Sheep from just $1 a month. Hello and welcome back to youtube.com/Wi-Fi Sheep with me, Tom. So, running RISC OS on RISC-V. Well, as you've seen previously, RISC OS does work very well and runs natively on the Raspberry Pi. That's mainly due to the Raspberry Pi being powered by an ARM processor. You see, RISC OS was basically the original system developed by Acorn for the ARM chip, ARM originally standing for Acorn RISC Machine. And as a result, a lot of RISC OS was hard-coded in ARM assembly language. But 30 plus years later, and it now leads to a problem. You see, this ARM assembly language only runs on certain ARM-based processors, and has had to be modified even to run on newer chipsets such as those in the Raspberry Pi. The result is RISC OS is far from being portable, and actively it supports very little ARM chipsets, hence why you've never seen ports to other platforms. So, in answer to the question, can you run RISC OS on RISC-V as a standalone sole OS? The answer is sadly no. But that doesn't mean we can't get it to run if we compromise and look at emulation. We've been really pleased to welcome PCBWay.com, your one-stop solution, as our title sponsor and supporter for this and many other projects here on Wi-Fi Sheep. And PCBWay are ready to help and support you too in your own maker journey. Just take a look here at PCBWay.com/projects at all the amazing and diverse things people are creating with PCBWay's wide range of production tools and services, such as 3D printing, injection moulding, CNC machine tooling, sheet metal fabrication, and of course, turnkey PCB manufacturing. And PCBWay even have their own product store with hundreds of really cool and useful items, which can be purchased like a regular online retailer or using PCBWay's credit bean system, given away as free gifts to customers of PCBWay's production services and products. PCBWay really are a truly fantastic partner to have for your maker journey needs, so don't miss out. Sign up for your free account today at PCBWay.com. Details and links are in the description. Now, emulation has been used to great effect over the last decade, especially on the Raspberry Pi, to achieve all sorts of things and to get programs and software running. RetroPie, with all its various game systems and platforms, is a prime example. This approach for RISC OS would be ideal, as the emulator creates a virtual chipset architecture and memory map for the classic OS and its software to run in, whilst interfacing with the newer hardware of the host machine or platform. And luckily for Acorn RISC OS, there is a well-supported and free emulator called RPC-EMU. We've covered this before on the channel when I showed you the RISC OS Direct for Windows build, which basically allowed x86 Windows PC to run RISC OS. Now, RPC-EMU for Windows is a simple download and install executable binary, as the program is pre-compiled for you, and that's great if you're on PC. But what if you want to run RPC-EMU on, say, a Raspberry Pi clone ARM board, or in our case, the RISC-V chipset architecture? Well, we'll have to compile RPC-EMU ourselves. And this is possible due to the free open source nature of RPC-EMU. Now, the idea of compiling software, especially for the first time, can sound very daunting. However, it's not that difficult to do, and the process I'm about to show you should work across most Debian and Ubuntu Linux distros, regardless to the architecture or hardware platform. Okay, so hopefully you've all seen the Mango Pi already in the initial review video, so I won't go over that again, but just for a very quick recap, it's effectively a Raspberry Pi Zero profile or format development board based on the Allwinner D1 chipset architecture, which is a RISC-V based architecture, so it's not ARM like many of the other dev boards you find on the market. And we're running an operating system from SD card, and this was some sort of unofficial port of Armbrian. Anyway, there we are. So I'm going to get this set back up, and next thing you should see should be the boot and the desktop. And if we power up, we'll see if the thing is still alive from last time. Because bear in mind, I've not used it since last time, so this is the first time back. So hopefully everything is as we left it, and we can carry on with what we're meant to be doing today. Okay, that's a good sign. If you remember, this thing did take quite a while to boot up. It's not a fast chipset, and this Linux being an unofficial port of Armbrian is not, I don't think it's meant to be running on this board actually. It does run, it runs okay, but yeah, so it's going to be interesting to get this one working. It's going to run slow. I think we just have to accept that. Right, and if I can actually remember the password this time, so it's and hopefully that'll be accepted and let us in. It will. I'm pleased to say the mouse driver is also working, which is a relief. Okay, so for this to work, we do need to be online, and in this case, we're using the onboard Wi-Fi, which was set up in the last video when we initially reviewed this device. And from applications, we're going to look at the terminal emulator. I'll pop that over there. And we're going to look at the web browser, and we'll go with Dillo. We don't need anything fancy. Dillo is a very fast but simple web browser, and that'll do fine for what we need. Okay, so here we'll head over to Google, and we're going to search for RPC EMU. It's the first link here, RPC EMU from Martin or Mutan.net. As explained in the introduction, this is the emulator that we are going to use. So in order to make this work, we need to compile it. If you're on Windows or Mac, I believe they are ready to go versions already made for you. But for everybody else, including us on this RISC-V dev board, or RISC-V dev board rather, we need to compile. So we're going to look at how to compile from source for Linux, which is here. And this is quite nice because it gives you the basics of what you need to make this work. Okay, so to make life a little bit easier for myself, I've just got the required text here in a mousepad, which is the Linux equivalent of a notepad document. So we should be able to simply copy and paste straight into the terminal. And of course it wants the password. Which is your login system password. And what we're doing here is we're installing the required dependencies in order to build RPC EMU. So it's going to use 75.1 megabytes of disk space, and it says, do we want to continue? So we'll say yes, we do. And you can see it's now going to install these dependencies. So these are things like the libraries and third-party sources and things that RPC EMU actually uses to work. So it shouldn't take too long to do, even on a machine running relatively slow, which this one is. Okay, so the next bit then, so it says here about downloading and uncompress source code. So let's go back and let's take a look at downloads, and we can download the source code. That's going to put it in temp for us, so we'll go OK. Okay, so let's just have a quick look and let's go and find our temp folder. So to do that, we'll head over to the file manager, and in the window that appears it's file system, and you'll see the TMP or temp folder, which we'll double click on, which is here, and there is the file. So we should be able to right click and hit open terminal here. There we go. Now if we copy the second line, paste here, and make sure we change the version, and we want to be dash version 0.9.4. Okay, and that has opened up, so we should be able to go ls, and there is RPC EMU. So what we'll do now is we need to go into the folder, and here is the directory we need. And again, just make sure we change the source, or sorry, the version number 0.9.4. Just check everything is in there, which is correct. And we're going to activate this build sh file. So we go /build.sh, and we should be able to simply say make. And there it is, actually compiling RPC EMU for the RISC-V or RISC-V chipset. Now this is going to take a little while, so we'll cut back when it's finished. Right, so about half an hour later, and there we go. It looks like it's probably built it successfully. And we can have a look up here, and there is a folder, and in that folder there is RPC EMU interpreter. Now this won't run immediately. We do need to add a few things, including some ROMs. Where do we get ROMs from? Well, let's go back to the website and let's take a look at using more tutorials for RPC EMU under Windows. And it talks about here about downloading the RISC OS 3.71 ROM. Now, you can run RISC OS 5, you can even run RISC OS 5 RISC OS Direct, as you've seen on the channel. However, ironically, I would actually recommend running the much older 3.71, which was the last version of RISC OS officially released by Acorn. It is also the one that is still compatible with most of the earlier 26-bit Acorn Archimedes software. So let's download this ROM, and again we'll put it into the zip folder. Okay, there is a ROM. Can we open? You can do this bit by command line, but I'm just going to do it in the interface as we've got it open. So, yep. We want to extract files. Extract. Excellent. There is a ROM. We could cut actually, but I'll copy into ROMs and we'll paste there like so. Okay, now then, we've got a ROM. This should work. Let's have a look. Oh, that's a good sign. We'll give it a minute. I have no idea how well or how fast this is going to run. That is a good sign. Oh, there we are. Wow. Okay. How usable is this? It's not bad. It is slow. You can see the draw rate on it is very slow, but it isn't actually bad. Full screen mode. Control N. This is the moment where we get locked out of the system. I don't know if I've got an N key on this, but okay. Host FS. It's actually not bad. It's a little clunky and slow, but here we are. This is RISC OS running on RISC-V or RISC-V chip architecture. So look in the built-in apps, Paint. Okay. Why is it whenever I do a Paint demonstration, it's always something really rubbish that I... Okay, that is slow. Yeah, that is yeah. Oh, that's terrible. Okay. F12 work? Doesn't seem to. Oh no, there we go. And can I ask for basic? Can I ask for, oops, the keyboard is not very responsive. Mode 1, nope, hang on, caps lock. MODE 1. Color 128 plus 3, CLS, color 0, list. Yeah, BBC Basic is there and running, and it's okay. It's slow, but it's better than I thought it was going to be. I'll be honest with you. Okay, final thing to do, which I forgot to do, and you haven't seen it in the video, but I did a restart and lost everything and had to recompile again, is to make sure that you do actually copy your compiled RPC EMU folder out of your temp directory and put it somewhere more permanent. So all I've done here is I've literally just done a right click copy and I've just pasted it onto the desktop. So it's here now. And we just double click and that should run fine. By the way, the instructions I've shown you will work on Raspberry Pi with Raspbian Linux, and the Ubuntu builds will work with it fine. You may find with the Raspbian builds that it will want to ask you for dialog if you want to execute the program, and you just click execute. Here on this version of Armbian, it's just running straight through. But as you can see, it's slow, but it's running. So as you can see, this does work, but we have to remember the current all-winner D1 RISC-V chipsets are quite slow by modern standards. And the build of Armbian used is not really optimized that well for the board, hence we're not seeing the best operation performance of RPC EMU, which in turn is making RISC OS run about ARM2 level speeds. Saying that, if we had tried this on faster chipsets, we might get some quite usable results, and I'm sure RISC-V or RISC-V architecture will continue to improve if it's not already there. Now, just returning to the RPC EMU downloads page, there is a button labelled Buy Me a Coffee, which is a monetary tipping method for the authors and maintainers of RPC EMU, which without their work and support would not make this possible. So please do consider making a contribution if you feel this has been of some use to you. Also, if you have an all-winner D1 RISC-V type board running Linux or Ubuntu and want to give this a try, but don't feel like compiling and setting up yourself, then I've made the new pre-build available to general support and downloads tier Patreon backers and Base Plus support members on YouTube. But I stress RISC OS and RPC EMU are both free and you can just follow what I did in the video. For Patreon, visit patreon.com/Wi-Fi sheep. That's patreon.com/Wi-Fi sheep. Or for YouTube channel members, click the join button under this video. And a quick look at the wonderful Patreon and channel members that continue to back Wi-Fi sheep and make all this possible. Thank you all so very much. Well, I hope you've enjoyed this video. If you haven't done so already, please do consider liking and subscribing. And as always, thank you so much for your company. I'll be back with much more real soon. So until next time, bye for now.